So we're going to continue with the introduction to function notation. Function notation intro. Since inputs and outputs are so important, we've come up with a way to write equations that highlights the input and the output. So up at the top, I'm going to add in a couple notes. We have learned that input is the same thing as your x, which is the same thing as your domain. Then we have our output, which is the same thing as y, or your range. So function notation is where we're going to write it a little bit differently. So if we look at example 1, it says the notation c of x tells us that the cost for a particular input or food in the chart. A couple things I want to point out is first c of x. That looks like c times x, but is read as c of x. So when we have things written like that, that's actually how we would write our output, c of x. Now, if we were talking about the input, that is just the x value. So there's your input. The whole entire thing, c of x, is your output. So let's continue further down. Letter A. What is c of hamburger? Meaning, what is the cost of a hamburger? Well, if I look at the chart off to the right, I can determine it just like if you're going in and ordering a meal at McDonald's. A hamburger costs us $1.50. So I'm going to put that over at letter A, $1.50. For letter B, what is C of shakes? So what is the cost of a shake? Well, when I go over and I look at the menu, cost of a shake is $1.55. So both of those are our inputs. A and B are talking about our inputs. For letter C and D, these are talking about your outputs. So for A and B, when you put in a hamburger, you get the cost of $1.50. When you input a shake, you get a cost of $1.55. Now for letter C, it's saying what item are you going to get if you get the cost of $1.05? So when I look over at my menu, $1.05 are French fries. So then for letter D, what is X when the cost is 70 cents? Well, this one might be a little bit more challenging to find just because it doesn't pop up immediately. But when you look off to the right, you got milk and coffee. That just says 70. That's referring to 70 cents, not $70. So when you're paying 70 cents, that's going to be either milk or coffee. So example 2, the notation n of x tells us how many yeast cells are in a counting square after x hours. So n of x, we used to just write that as y. And then x still just stays as x. So this is saying what is y when x equals 10? So again, this is n of x. So it's saying your x value of 10. So if I look over here, 10 hours, that equates to approximately 600 cells. For letter B, what is n of 4? Meaning after 4 hours, how many yeast cells do you have? So after 4 hours, it's right about there. So it's not quite 150, but it's not 0 either. So let's just estimate and say that it's going to be 100 cells. If you said 75, that's appropriate too. So both of these, we're solving given the input. We had the input, we had to solve for the output. For letter C and D, they give us the output. So that means that we had to solve for the input. So what is x when n of x equals 300? Well, that means that this time I want to go to my y values. And it's going to be right about there. I did add in a little point that's give or take about at, let's say, 6.5 hours. If you said 7 hours, that would work. If you said 6 hours, that would also work. Again, some of this is just estimating. For letter D, what is x when n of x equals 665? Well, this one's a little different because it does show you a dashed line. That dashed line indicates that the highest it gets is 665. So that happens at approximately 15 hours. So example 3, the notation B of name tells us the birthday month and day for any student's name. So if we look at Joe, his birthday month and day is March 15th. Anna is June 30th, Phil is April 19th, Terrence is February 10th, and lastly we have Shannon at December 5th. So we're going to complete the chart with a few more values from your class. Letter A, what is the birthday of Anna? Well, I'm going to find Anna, and her birthday is June 30th. Then for letter B, what is the input for the name of April 19th? So letter B is giving us the output. We need to figure out what name matches up with April 19th. So April 19th is going to be Phil. For letter C, for the birthday of Terrence is February 10th. What's the input? What's the output? The input is Terrence. The output is February 10th. So if we expand this function to describe all students, letter D is asking, why would we want to use student ID numbers instead of first names? Well, if we go back and we look at this table, we have Joe, Anna, Phil, Terrence, and Shannon. That's only 5 students. Some classes might have students with the same name. So let's say that there are multiple Joes. Well, you might not know which Joe we're talking about. So if each student has a unique student ID number, then that would provide us with knowing exactly whose birthday was what day. So helps to differentiate between students with the same name. Letter E. Will there be more than one input for a given output? Explain. Well, if you have students with the same name, so number 1, we're going to do some practice. We're going to let X equal the ticket price in dollars. So again, X is the ticket price in dollars. That's over here. Then P of X is the profit in millions of dollars for that ticket price. Remember, up until this point, we've actually been using Y. So instead of Y, we're going to say P of X. So we're going to find the price of $350. I'm sorry, we're going to find the profit of $350. So if it costs $350, the profit is going to be $3.82 million. So it does say in the chart 3 and 82 hundredths, or 3.82, but then at the top it says millions of dollars. So I'm going to make that $3.82 million. For letter B, what is X when P of X equals 3.52? Well, remember, P of X is also representing our Y. So we want to go in and look at our chart and find 3.52 for the profit. The profit of 3.52 makes the ticket price $250. So now we are going to let X equal the time in seconds. Let h of X equal the height of an object. Use our input and output lines and estimate values on the graph. So we're going to find that height at 0.8. So you know what? Our graph over here doesn't really have enough information, so I'm going to add a little bit more. So it says let X equal the time in seconds. So let's add that in. Time in seconds. And then let h of X equal the height of the object. Again, we're going to make this h of X, which up until now we have been using Y. So we're finding the height after 8 seconds, or 0.8 seconds. So using my highlighter, I'm going to highlight up from 0.8 of a second, and that equals about, let's say, halfway between 5 and 6, give or take. We're going to say 5 and 5/10. And you know what? It doesn't say exactly what our height is, but let's say that it's going to be in feet. I'm going to add that over here. Letter B, what is X when the height is 4? So this time it gives us our output, our Y value. So when you have a height of 4, it's actually going to hit at 2 separate times. The first one is going to be at 0.2 of a second. And at approximately, let's say, 0.9 of a second. Well, now we're going to find the height at 0 seconds. So you'll notice I am using different colors. If it helps you, feel free. You don't have to use the highlighting. But that's going to give me a point at about, let's say, 1.2 feet. For letter D, we're going to find out our X value when we have the height of 0. So the height of 0 is all the way down here at almost 1.2 seconds. So we'll say that's 1.95, give or take. So some of these we're just going to be estimating. If you would have said 1.9, that would have been appropriate. Oh, I apologize. It can't be 1.9. It could be 1.19. And the reason being, 1.9 is much larger than 1.2. So we can say it's 1.19 seconds. Not quite 1.2, but close. So letter E says in words, what does the height of 4/10 of a second equals 5.8 communicate about the situation? This says at 4/10 of a second, the object is 5 and 8/10 feet high. All right, so let's move on to number 3. The chart gives the monthly average water temperature of the Gulf of Mexico and Key West, Florida. We're going to use function notation to say that the average temperature in March was 75 degrees. So we're going to label that as the temperature in March equals 75 degrees. Because the temperature is going to be your y value, so we'll say that that's T of x. And then our month is going to be our x values. So I replace the x with the month and the temperature of that month and make it equal to it. That's where my 75 comes in. So number 4, it says the graph shows input-output pairs for the function of f. Use the input and output lines to answer. So we're going to find f of 4. So remember, this means that x equals 4. So we want to find our y value. So when we have x equals 4, that means we go to the right 1, 2, 3, 4. It's going to be this point right here. That's up 1, 2, 3. So that means that f of 4 equals 3. Now we need to find f of negative 3. So that means that x equals negative 3. So I go to left 1, 2, 3. And here's my point. I go down negative 2. So y is negative 2. This means that my f of negative 3 equals negative 2. For letter C, solve for x. F of x, which is your y, equals 4. So that means that this time, instead of going left or right, I'm going to go up or down. So I want to go up 1, 2, 3, 4. That matches up with this point, which is at 1. So that means x equals 1. And then we're going to solve for x. F of x equals negative 2. So that means we have y equals negative 2. Again, f of x refers to our y value. So I'm going to go down 2, and then I'm going to circle, well, this time I have 2 points, negative 2 and negative 3. Wonderful job. Let's continue. So solving function equations. Solve using function notation, solve your work, and write final answer in function notation. What is the value of y for the function y equals negative 2x plus 7 when x equals 2? Well, we're going to take our function of y equals negative 2x plus 7, and instead of putting in an x, I'm going to take the number 2 and plug that in. So y equals negative 2 times 2 plus 7. So simplifying, y equals negative 4 plus 7. So y equals 3. So what's the value for y? 3. Let's try number 2. What is the value of y for the function y equals 3x minus 15 when x equals negative 22? Well, this time, instead of x, I'm going to put in a negative 22. Y equals 3 times negative 22 minus 15. Now, if you're wondering if you can use a calculator, yes, you can. 3 times negative 22 gives me negative 66 minus 15. Negative 66 and 15 are both negative, so that means I'm going to have a bigger negative, so it's negative 81. So all we're doing for number 1 and number 2 is we're taking our values that they provide, whether it's an x or a y, and plugging it into our function, which we have talked about them being called equations up until now, but taking them and solving for our unknown variable. So number 3, what is the value of the input for the function, the quotient of the input, and 4 less than 5 when the output is negative 8? So what is the value of the input for the function, the quotient of the input, and 4 less than 5? The quotient of the input. Quotient means division. So we want to be doing some dividing of the input and 4 less than 5. So we're going to take the input, which is our x value, and 4 less than 5. 4 less than 5. Less than means minus. I apologize. It says the quotient of the input and 4 less 5. So I apologize. The quotient is talking about division of the input and 4 less 5. So our input is x divided by 4 less 5 means 4 minus 5. And the output is negative 8. So that gives me negative 8. So simplifying, x divided by 4 minus 5 equals negative 8. So I just rewrote that into fraction form. So x divided by 1 equals negative 8. X equals negative 8. All right, part 2. We're going to find the indicated value for the function and show our work and write our answer in function notation. So we have f of x equals 4x minus 7, f of 3. So that just means that I'm going to write this as f of 3 equals 4 times 3 minus 7. All this is telling me is that instead of writing an x, I'm going to replace that with a 3. So same thing over here, I'm going to replace it with a 3. So 4 times 3 is 12 minus 7 gives me 5. So f of 3 equals 5. So this is also read as x equals 3, y equals 5. So we're going to do the same equation, or I'm sorry, the same function, but this time we're going to have f is negative 5. 4 times negative 5 minus 7. 4 times negative 5 is negative 20 minus 7 gives me negative 27. So f of negative 5 equals negative 27. Number 2, same idea. G of 4 is negative 3 times 4 plus 10. Negative 3 times 4 is negative 12 plus 10, which simplifies to negative 2. So G of 4 equals negative 2. For letter B, g of negative 9. That is negative 3 times negative 9 plus 10. Negative 3 times negative 9 is 27 plus 10, which simplifies down to 37. So g of negative 9 equals 37. Number 3. This time we have some exponents. G of 6 equals 6 squared plus 5 times 6 minus 1. So even though there's exponents, that's okay. We can still replace our variables. So 6 squared is going to give us 36. 5 times 6 is 30 minus 1. 36 plus 30 equals 66 minus 1. So that's 65. G of 6 equals 65. Let me correct that G. For letter B, we're new G of negative 4. So same equation, h of x. Oh, I apologize. Number 3 should say G, not H. But anyway, so G of x equals x squared plus 5x minus 1. So it's going to be negative 4, that quantity squared, plus 5 times negative 4 minus 1. Negative 4 squared, if I put that in my calculator, that's going to give me a positive 16. You can also do it by hand. Negative 4 times negative 4 gives me a positive 16. 5 times negative 4 is negative 20 minus 1. So 16 plus negative 21 gives me the answer of negative 5. So G of negative 4 equals negative 5. For number 4, f of x equals negative 2x squared minus 3x plus 8, f of 5. So negative 2 times 5 squared minus 3 times 5 plus 8. So negative 2 times 25 minus 15 plus 8. Negative 50 minus 15 plus 8. Negative 50 minus 15 is negative 65. Plus 8 gives me negative 57. So f of 5 equals negative 57. Letter B. Negative 2 times quantity 0 squared minus 3 times 0 plus 8. So it tells me that my x value is going to be 0, so I'm going to replace it with a 0. So negative 2 times 0 minus 0 plus 8. So that becomes 0 minus 0 plus 8, which simplifies to 8. So f of 0 equals 8. So for the following functions, we're going to find the range for the given domain. We're going to show our work and write our answer in set notation and in function notation. So f of x equals 2x plus 7, 5, 18, negative 5. When I go back to the directions, we're going to find the range for the given domain. They give us the domain. That means they give us our x values. So these are all of our x's. So we are going to write it as f of 5 equals 2 times 5 plus 7. 2 times 5 is 10 plus 7, which is 17. So f of 5 is 17. Our next value is 18. So I'm going to write f of 18. 2 times 18 plus 7. 2 times 18 is 36. You add 7, that gives you 43. So f of 18 is 43. Lastly, I have f of negative 5. So this becomes 2 times negative 5 plus 7. 2 times negative 5 is negative 10 plus 7, which becomes negative 3. So what I'm doing for these three problems is I'm taking my 3x values, 5, 18, negative 5, and I'm plugging them into my f of x. So let's try number 6. G of x equals 9 minus 4x. So G of negative 2 is 9 minus 4 times negative 2. So this is 9 plus 8, which is 17. So then I have G of 10. So 9 minus 4 times 10. So that's 9 minus 40. 9 minus 40 is negative 31. And lastly, I have the value of G equals negative 10. I'm sorry, negative 1. So 9 minus 4 times negative 1. 9 plus 4 gives me 13. Number 7. We have the function f of x equals 3x squared minus 1 for the values 2, 4, and negative 3. The first one, f of 2, equals 3 times 2 squared minus 1. So 3 times 4 minus 1 becomes 12 minus 1, which equals 11. Next, we have f of 4. 3 times 4 squared minus 1. 4 squared is 16, so 3 times 16 minus 1. 3 times 16 is 48. Minus 1, 48 minus 1 is 47. Let's try one more in this problem. We need to finish it off by finding f of negative 3. So 3 times negative 3 squared minus 1. That becomes 3 times 9 minus 1. So 27 minus 1 becomes 26. Number 8. H of x equals x squared plus 8x minus 1. So we have h of 1 for our first value. So 1 squared plus 8 times 1 minus 3. So 1 plus 8 minus 3. 9 minus 3 becomes 6. So h of 5 is my next value. 5 squared plus 8 times 5 minus 3. 25 plus 40 minus 3. 65 minus 3 simplifies down to 62. And then we have h of negative 2. So negative 2 squared, you need to put the negative 2 in parentheses, plus 8 times negative 2 minus 3. This becomes 4 plus negative 16 minus 3. Negative 12 minus 3, lastly, is negative 15. So we did a whole slew of problems, all written in function notation. So now you guys are going to go and get your homework, which is located in the front after you've shown that you have completed your notes. And then you can work on numbers 1 through 6. That is due tomorrow. Reach out with any questions or concerns.